Hello, Raen speaking. Welcome to the second episode of Project Austreya. In this episode, we'll shift our focus back to Austreya and take a look at how life began on this world. Before we do that, however, a few things. As mentioned in the last episode, Amadan is a red dwarf. Unlike yellow stars like our Sun, which has an estimated lifetime of about 13 billion years, a star like Amadan would likely live 10 times that long. That means Amadan could be as old as the universe itself, almost 14 billion years, and it would still be considered young. Now you might think that would give life a long time to evolve, but that's only in theory. In fact, it's rather unlikely for life to exist around such an early star. I will not go into why that is, that would be a topic for an entire video on its own, and that's not the subject of this series. For simplicity, let's assume the Amadan system formed around 4.5 billion years ago, making it around the same age as our own solar system. Moreover, I won't describe every life form that appears during the ages. That would be a project far larger than anything a single person could reasonably undertake. What I will do is giving a general overview, as well as pointing out some of the more remarkable clades and creatures. Now, let's talk body plans. There are basically three possible body plans. Radial symmetry, meaning the creature is arranged around the center, which usually contains mouth and anus. Bilateral symmetry, with front and hind ends, and asymmetry. On Earth, only very simple creatures are asymmetric, such as sponges or placozoans. For simplicity, we'll assume that it's the same on Austreya, so it's pretty much irrelevant. Also on Earth, most radial symmetric creatures are either sessile or slow-moving, while bilateral symmetric creatures are mobile or fast-moving. In the interest of completeness, there's also spherical symmetry, but that's usually only found in single-cellular organisms. And we're not going to talk about icosahedral symmetry because screw viruses. Finally, I'll try to create scientific names in Greek and Latin because that's customary. However, I have absolutely no idea about Greek or Latin, so I'm kinda winging it. Read Google Translate. If any of you know Greek or Latin and my attempts at creating viable scientific names give you the cringes, sorry. Anyway. This is Austreya 2.5 billion years ago. There is no life on the surface yet, and the atmosphere comprises mostly nitrogen with traces of carbon dioxide. There is, however, already life in the ocean, a variety of single-cellular organisms to be precise. One species, something similar to cyanobacteria, can be found all over the planet. They're extremely successful as they evolved autotrophy, the ability to create nutrients themselves by processing simpler compounds. They're doing this through photosynthesis. By using a light-sensitive chemical called retinol, they're capable of splitting carbon dioxide into carbon, which is then used to create nutrients, and oxygen, which is expelled as a waste product. By doing so, these bacteria are slowly enriching the planet's atmosphere and oceans with a gas that is poisonous to any other life currently in existence. This is called oxygen catastrophe. The majority of the fledgling life is going extinct again, killed off by the oxygen. However, some life forms learn to metabolize the oxygen by evolving aerobic respiration. These life forms begin to thrive and spread quickly. They're so successful because breathing oxygen is simply far more effective than anything that has existed before. Eventually, the first multicellular organisms appear, and we're slowly approaching the 1.5 billion years mark before today. At this point, Austreya has an atmospheric composition of 65.8% nitrogen, 32% oxygen, 1.2% argon, and 1% carbon dioxide. And here they are. This is Staterodiscos, meaning fixed disc. This flat creature has a circular, somewhat pancake-shaped body arranged around a single opening, which it uses to expel spores from for reproduction. At this moment, these guys are hard at work, even though it might not look like it. Staterodisci are closely related to the original bacteria which caused the oxygen catastrophe, and, like said bacteria, use photosynthesis to provide themselves with nutrients. They're also using retinol to do this, which is why they appear purple in color. But Staterodiscos is not alone in the ocean. These are Gyrozalia, meaning round swimmer. They may not look very exciting, but Gyrozalia are already rather advanced, at least for such early creatures. Not directly related to Staterodiscos, Gyrozalia have bilateral symmetric bodies with a mouth in the front, a through gut, and an anus in the back, which is also used to expel spores for reproduction. They feed off marine snow, plankton, and other nutritious particles that have fallen onto the ground. Also, they absorb oxygen through their skin. Gyrozalia have developed a very special ability. They are the first organisms not considered plankton that are capable of motion-powered swimming. Well, sort of. Every now and then they push themselves off the ground, flop around for a bit, and settle back down, hoping to land in richer feeding grounds. They can't do that very often or for a long time though, as it burns a lot of energy which their simple metabolism just can't replenish quickly enough. If a Gyrozalia tried to swim for longer than a minute or so, it would likely die from exhaustion. In a peaceful place like this, there is little competition. Still, Staterodisci capable of producing more spores are more successful. But producing more spores requires energy, and to get more energy, they need to photosynthesize more. To do that, they need a larger surface area, and the easiest way to gain surface area is to simply grow larger. However, there's an issue called the square cube law. Staterodisci likely have no awareness of this law, in fact they have little awareness of anything, but they're bound by it nonetheless. The square cube law states that increasing the surface area will also increase the volume, and the volume always grows faster than the surface area. This diagram shows the growth of a sphere. The horizontal axis is the sphere's radius. The blue line indicates the surface area, the purple line is the volume. If a Staterodiscos simply grows larger, it will need more energy just to stay alive. The greater its volume, the greater its demand, and at some point it will require more energy than its increased surface area can provide. That means they need a way to increase their surface area without significantly increasing their volume. The answer is introducing wrinkles and folds to the surface. They become Anisodiscos, from the Greek word anisos, uneven. Over time, these folds grow into flaps. These creatures are called Velodiscos, from the Greek velo, veil, because their flaps sway in the gentle currents like cloth. Let's go back a bit. When the Staterodisci began to change, the Gyrozalia started their own evolution. This is Pterygiozalia. The name means fin swimmer. The tail end became wider and the body is a bit more streamlined. They are still ground dwellers, but with the wider tail they can swim more effectively, allowing them to move around with less effort. They also evolved rudimentary gills on their backs, allowing them to absorb oxygen more effectively and thus swim for longer periods. To distribute the oxygen from the gills, Pterygiozalia evolved an open circulatory system. Its organs are inside a cavity that is filled with a hemolymph-like liquid. They basically float within the liquid and are constantly in contact with it. Finally, Ich krieg's nicht hin, diesen scheiß Namen korrekt auszusprechen. Ja, was muss ich aus so einem komplizierten Namen machen? Das nächste Viech nenne ich Hans oder was weiß ich. Finally, Pterygiozalia is the first creature on Austreya to evolve eyes, although they are quite primitive. Two small clusters of photosensitive cells at the sides of the head allow them to tell light from darkness, so they don't bump into obstacles. At the same time the Velodisci appears, another successor of the Gyrozalia makes its debut. This is Vermizalia, a swimming worm. A distant relative of Gyrozalia, these little guys have evolved a lot. Their bodies became long and thin, while the tail end evolved into a vertical fin. Vermizalia are the first creatures to spend most of their lifetime swimming. However, they have no gas bladder and thus have to swim constantly, otherwise they would sink to the ground. And they do when they are sleeping. They also possess gills at the sides of their bodies, and they have eyes similar to the Pterygiozalias, albeit with one difference. This is how a Vermizalia would see its environment. As you can see, it can determine only between light and darkness, except for one little detail. These purple spots are, in fact, Velodisci. While its relatives still feed off plankton and marine snow, Vermizalia has discovered that there is something much more nutritious out there, the aforementioned Velodisci. When a Vermizalia spots one, it will swim up to it and use its mouth to rip out small portions of the flaps. Vermizalia feeding off of it does not kill a Velodiscos, as the base can still photosynthesize, but it will decrease its effectiveness in producing spores. Now, let's return to Earth for a moment. Between 541 and 485.4 million years ago was the era we call the Cambrian period. It is so significant because of an event we call the Cambrian Explosion. Life existed before, but up to that point it was lacking diversity. However, in the Cambrian, this suddenly changed. Well, suddenly in geological terms, which means within a period of around 5 to 10 million years. Life and diversity exploded, and creatures appeared that were more alien than anything ever seen in movies. We're still not entirely sure what exactly caused the Cambrian explosion, but there are a few factors we assume played a major role in it. One was the recent abundance of oxygen. Another, we'll talk about that in the next episode of Project Austreya. That's it for now. Thanks for watching. If you enjoyed the video and would like to know when the next episode comes out, well, at this point you know what to do. See you next time. Raen out.